Algebra 1, Section 1, 2. Let's begin by talking about these three words: simplify, evaluate, and solve. They mean different things, and oftentimes they get confused just through sloppy language or sometimes as a more serious error. The first two are similar. Simplify and evaluate mean almost the same thing. Simplify means just that, to simplify. If you're given something in algebra that you can use orders of operation, we're going to talk about those in a minute, to make it simpler, to make it, less numbers, symbols, and variables, for lack of a better explanation. If you can add things, subtract things, get rid of parentheses, simplify in the true sense, you should do that. Evaluate basically means plug it in and simplify, and we'll see examples of both of these in the lesson. Evaluate means that you would be given the value of a variable, or variables plural, and then you're going to plug those in, and then the direction then becomes to simplify. Solve, on the other hand, is very different. And if you recall in the last lesson, I talked about expressions versus equations. Well, simplify is something you can do to an expression, whereas solve is something you can do to an equation. So that's what solve is. Now, again, with this lesson, we will deal with simplify and evaluate. Solve is actually something that's coming later. In fact, we have a few chapters devoted to solving. Okay. And again, I bring that up because a lot of times students will say, well, okay, so I solve it out or something like that, when what they mean to say is simplify. If it's an expression, you're not solving anything. Solve is to actually find out what number or numbers would go in for the variable to make the equation true. We're not dealing with equations in this chapter, so we'll be simplifying. Okay, now you've probably seen this before, PEMDAS. Some people will just say it as a word like that. You've probably heard, please excuse my dear Aunt Sally. I prefer push Eddie Murphy down a staircase, but you can make up your own if you want to. And if you like Eddie Murphy and you don't want to push him down a staircase, then pick a different EM. How about Elon Musk? Push Elon Musk down a staircase. Anyway, we remember it that way because what we need to know mathematically is that the P stands for parentheses. The E, I think I spelled that right. Please excuse my spelling if I didn't get parentheses right. I think that's right. The E is exponents. The M is multiplication. D, of course, is division. A is addition. And S is subtraction. Now, one thing to note about this is CTION. One thing to note about this is that, of course, these are the ways, this is the order in which we should simplify things. Get rid of parentheses first if you can, then look for exponents then. And what you need to know is that multiplication and division are on the same plane. Addition and subtraction are on the same plane. It is not that multiplication supersedes division. It is not the case that addition supersedes subtraction. They are actually together. So when faced with, let's just do a real quick, 5 plus 7 minus 3, what do you do first? Well, you do left to right first. Okay, so you should go 5 plus 7 is 12, minus 3 would be 9. Okay, and this, for the example that I just picked, it may not matter, but sometimes it does. So just when faced with two operations that are on the same plane, like multiplication and division, addition and subtraction, we resort to then left to right. It would kind of be like the last thing you should know. Okay, and then the only other part to note before we just run through some examples is powers. Here I have n to the x, and then I have some examples here. 2 to the third, we should be able to simplify that. That means 2 times 2 times 2, which would be 8. X to the fifth is another example. 9 to the x is yet another example of an exponential, and we'll talk about those. I think it's chapter 8, if I remember right. Anyway, the anatomy of a power is that this number is the base number or variable, and this is called the exponent, as mentioned above in PEMDAS. Okay, so let's look at some examples. Simplify, we talked about what that means. Simplify, and we want to follow the orders of operation. Now this is 32, which nothing can be simplified. 6 squared, notice there's no parentheses that we could multiply something to get rid of. So I'm moving to exponents, and I can simplify this. 6 squared, 6 times 6, that's 36. And since it's separated by a minus sign here, I can go ahead and also do 14 times 3. That would be 42, okay? And now, just as I just said in the last example, let's just take this left to right. 32 plus 36 would be 68. 68 minus 42 would be 26, if my mental math is any good, okay? And just a quick word about work. Yes, you should show work on a problem like this, and I do require work. I am not ridiculous when it comes to requiring work, so I don't think, actually I probably can show you ridiculous right now. You see all that work? I mean, does it take 4 lines to do that? Practically 5 lines. Of course, it doesn't take 5 lines, but some work should be shown. This is how you indicate to me that you know what you're doing. So, 1 line of work here, is that unreasonable? I don't think that it is. And it comes out to 26. Moving on to the next example, here's evaluate, right? The last one was simplify, this is evaluate. And the reason that it's evaluate is because you really couldn't simplify this much, okay? If it just said simplify, you could simplify the 3 squared, and that's probably about it. Maybe you turn this into a fraction, maybe. But the fact that they told us that x equals 2 means that we can plug 2 in here. The fact that they told us that p is equal to 3, we can plug 3 in here. And now we have 5 times 2 plus 3 squared divided by 3, right? P is 3. Okay, now I like to use parentheses here. If you used a times dot here, that would be fine. Let's all get away from the times symbol though. So if in your work, if you would go 5 times 2, change that. That's a dangerous thing to do in algebra. Don't use the times symbol. We're kind of moving beyond that. I'm sure you've seen the times dot before. That's fine. Parentheses also indicates multiplication. Okay, please do not use the times symbol. The only exception to that, I believe, in the whole book is when we do scientific notation in like chapter 8, 9, 10, something like that. Okay, so what do we have here? Well, 5 times 2 is 10. 3 squared is 9. When I do divide, I do like to put it as a fraction. That kind of helps me to know that there's probably a reduction that's going to happen there. So you can do that as well. And then 9 divided by 3 is 3. This is really 10 plus 3, which is 13. Okay, now they had about as much work as I did in this one. And maybe you could have done that in less work, and that's fine. But here's something else about work. Don't sacrifice a line of paper, a line on a piece of paper, for the wrong answer, for the right answer. Don't sacrifice, I should say it this way, don't sacrifice the right answer so you could save a little bit of room on your paper. That's what I meant to say. So if you got to show more work in order to get the answer right, it's worth it. Next one says find the total cost of a pair of jeans if the price is $32 and the sales tax rate is 8%. Here's probably where you're at with this coming out of 8th grade math, is that you know that 8% is 0.08, and you're going to multiply that by the cost of the jeans, which is 32, okay? And if you need to use a calculator on that one, that's okay. And then what you're going to do is you're going to take that result and add it to the cost of the jeans. So the tax on it is $2.56, and then you could take that and add it to 32, and you'll come up with $34.56. Now here again is something that we're going to try to move off of really quickly in Algebra 1 because there really is a better way to do that. There's a more efficient way to do this, and we can do it in one step. You see, as a decimal, 100% is just 1, right? And what are you paying for? Well, you're paying for 100% of the jeans plus 8% more, so 108% total, okay? So what we would do instead, rather than doing this step and then adding it, which is 2 steps total, so doing this step to get 256, add it to 32, what we want to do is just take the 32 and multiply it by 108%, which is 1.08. You multiply 32 by 1.08, you will get 34.56. And we were able to do that in one step instead of 2. And it's not just about saving us a little bit of time. We're going to want to be able to insert this concept into equations themselves, and you don't want to have to come up with a 2-step situation when it can be much easier, as I showed you. Either way, we get 34.56. This is the more efficient way to do it, though. Next one, simplify 3 times 8 plus 6. You got parentheses in this one, divided by 4 squared minus 10, also in parentheses. So let's go ahead and simplify what's in parentheses first. 8 plus 6 is 14. Probably can do this in one step, right? Because 4 squared is 16, minus 10 is 6. If you need to do another line, that's totally fine. And then 3 times 14 is 42, divided by 6, or maybe you do like a fraction like I did the last time, and that's going to be 7. Simplifying. A couple more. Evaluate each expression for x equals 11 and z equals 16. Notice that these are very similar. Xz squared, xz squared. You can even say it and it sounds like you're saying the same thing. But in fact, these are very different. I'll show you why. X is 11, z is 16, and we're going to multiply those first and then square them. Now contrast that with this, 11 times 16 squared. Is the 11 being squared in this one? It is not, right? The parentheses in this problem are indicating that the product of the two is being squared. Here, this is 11 times 16 squared, right? Very different. Okay, let's go back to the first one now. 11 times 16 is 176. And when I square that, and yes, I'm using a calculator, I'm pretty good with mental math, but I'm not that good. 30,976. Whereas here, and I just think of things and I'll just kind of insert my little caveats, if you will. If you can do this, well, what do I want to say? 16 squared. If you can do that on your calculator first and then multiply it by 11, you're doing that a little bit more orders of operation way. The orders of operation way, you're maybe get a little bit more out of that problem than if you just go to your calculator and type in 11 times 16 squared. Yes, you'll get the right answer, but there's more to life than just the right answer. Okay, so either way, that would be 2,816. That is the correct answer. But again, because we're emphasizing orders of operation here, 16 squared, that was 256. The exponent came first, then we do the multiplication. We're just following orders of operation there. And one more. This would be the toughest one. The bracket just means outer parentheses. So let's kind of tackle this from the inside out. 2 times 9 is 18. I can go ahead and simplify that out inside the brackets. 15 divided by 3 would be 5. And really the brackets could turn into parentheses now. I wasn't anticipating that to drop off so quickly. Let's see. Then 18 plus 5 squared, you probably can do this one in 2 steps in one line. 5 squared is 25, and then add that to 18. That would be 43. Here, I'll use the times dot this time. And then 4 times 43 will give us our answer, and that is 172. Really get your orders of operation tested right away here. But that is the correct answer. Okay, thanks for tuning in.